non-remembering the models. Model 2. Let's see what it is first. If you are familiar with DC motor control, you may recognize the system structure. This is a DC motor, and we have inner PI controller and outer PI controller, double loop DC motor drive. So the name of the parts are already been given. So if you want to design the controllers for the system, your motor drive course, I think you have to consider the inner drive, inner controller for inner loop first, and then consider the outer loop, which could be rather complicated. Now, I introduced the ITAE criterion to the error signal, and then perform simulation to the problem, and then I can design the two controllers. So there are two parameters to be used: KP1, KP2, KI1, and KI2. And this is the model. I name it as my model 2. Now I can run the OCD program, Optimal Controller Designer, and the program is something like this. And in the program, first I should link it with the existing Simulink model. I use the My Model 2. You can either tag a string My Model 2 here, or click this one to search a model from the list. It is standard Matlab, standard file name dialog box. So we can specify a model name here, and then we can use the parameters KP1, KI1, KP2, KI2 in whatever order you want to write them. You have to separate the variable names by comma. And then you have to select a TF value, because for the system, the response is very fast, so I can select smaller value. You can later check the value whether it is correct or not. If it is not correct, you can modify it. So these are the only three important properties you have to specify: the model name, the variables to be optimized, and the finite time. Then we can click icon here to create automatically the Matlab function to describe the objective function. You can view the objective function by clicking this button, and this one is automatically generated one, which is quite similar to the one I used earlier. We code My Model 2 here, and we specify the interval from 0 to 0.6. So this is done automatically. Now we can initiate control, and we can open the scope. If this result is not satisfactory, then we can delete the result of 10 and perform optimization again. And also we can use other methods such as genetic algorithms to find the global minimum of the system. As I have thought, the mean search, there are limitations in it, because you have to specify x0 by hand or by random numbers. If this one is not properly chosen, then the result obtained may be the local minimum. How can we solve this problem? How can we find the global minimum problem? How can we find the global one? There are several ways. One is to select several x0s and see which one gives the best results. The other one is to introduce other methods such as genetic algorithms. I'm not going to go into too much detail about genetic algorithms. Later in the course I will show you how to use genetic algorithms. In the program, what you need to do is just to select the method, optimization method in the list box. For instance, you can select genetic algorithm and direct search toolbox, and then create the function again and perform optimization. And this normally will give you the global optimum value for the system. It may take some time. It will run much slower than the conventional optimization problems, such as F-mean search. Will run slower, but normally it will get the global minimum. Today there is no method which can be used universally any optimization problem with global minimum. You can try several methods such as genetic algorithms and other methods. That's slow. And I will explain genetic algorithms later on in the course. And you can see that it is getting better and better. You can imagine that it is so slow. So let's move on to today's lecture. Oh, I think we can, well, this is not the global minimum. Maybe we can use another toolbox. So we still need time. So any questions? So what is the OCD? I think sometime later on I can get the file to the Google pages at Google Pages. And without OCD, you can just follow the command I use. It is similar. To map the original problem into optimization problem and then solve it. That should be okay.